In this third part of the tutorial, we will be looking at folds. Folds occur where the stress being applied to the rock causes the rock mass to deform plastically, rather than in a brittle manner, which would cause breakage and therefore faults. Faults and folds therefore can occur under the same stress regime depending on the nature of the rocks present, and therefore you can get both folds and faults occurring together in different rock layers. It is often the case the younger strata deform plastically, being less cemented and therefore softer, while older, more highly cemented strata will break, creating faults at depth, overlain by folds in the cover strata. A fold is a deformation of the originally horizontal layer or layers, and can either be bending upwards, antiforms, or downwards, synforms, often occurring as a train of folds where both occur successively. Antiforms are called anticlines if the succession is the right way up, so that older rocks appear in the middle of the fold. Synforms are called synclines if the younger rocks appear in the middle of the fold. Since in most cases in petroleum geology the succession will be the right way up, we can use the terms anticline and syncline. On folds we can define the hinge, which is the maximum curvature, and limbs, sides of relatively similar dip. The crest of a fold is the line of highest points, which may or may not coincide with the hinge, depending on the orientation of the fold. Folds may be symmetrical, where the two limbs are the same length, or asymmetrical, where the limb length differs. All folds have an axis, a line on the hinge of the fold where the maximum curvature occurs, where the fold changes from one limb to the other. If you find the fold axis in all the successive layers that make up the fold, you define a plane in which all those axes occur, and this is known as the fold axial plane. Folded successions can be in any orientation, again depending on what stress field is causing the folding to occur. Folds may be upright, inclined, or recumbent. These definitions are referring to the orientation of the axial plane. The fold axes themselves may also be in different orientations. They may be horizontal, plunging, or vertical. Using these definitions, it is possible then to come up with a series of combinations of fold axis and axial plane orientations, like this set. For instance, here is an upright plunging fold, while this one is a recumbent horizontal fold. Folds may also have more than two directions of dip. These cases are often where some other factor is acting, like the interference of faults within the folded succession, or the presence of a diapir or other underlying structure causing dome-shaped folding to occur in overlying layers. These types of fold are often referred to by their closure orientations. Closure is where the structural arrangement of the layers is such that it creates a closed-in shape which can potentially trap hydrocarbons. In folds, this is where the limbs dip down to below the oil-water contact and therefore create a trap geometry. Folds can be two-way closure, three-way closure, or four-way closure in this sense. The last is sometimes referred to as a dome. Folds on maps are shown as a line indicating the location of the axis, with symbols to show plunge if present, and an indication of the dip on either side of the axis to indicate whether the fold is an anticline, an upfold in a normal succession, or a syncline, a downfold. I hope that these three tutorials have helped you to understand better the topics covered in structural geology. For more information, do see the notes and the PowerPoint slides, and in order to test your understanding, make sure to do the tests that are available in Vision.